Alright, hello YouTube. I've got a few demonstrations for you guys, right? So first of all, I've got this project called Perlin Line Generator, right? That essentially what it does is I've got a showcase here. So if I reload this page, it generates a bunch of points, right? In this canvas, p5.js canvas, right? And what it does is the brightness of each of these nodes, as you can see, decreases as you go further up, right? And that's well, I was playing around with some HSV values and the idea of inter-HSV color wheel, and so I came across an idea to formulate like this something that's like that takes in randomness and color to incorporate a beautiful piece of art, right? Incorporate into a beautiful piece of whatever. All right. So this is the first project, first showcase, right? So how is this implemented in code, right? So this is a code walkthrough, right? I'm not the best coder out there. I've only been coding for the past year or so, like actually coding. So this might not be on par with what you're used to seeing, but nevertheless bear with me and hopefully you too might learn something from the set of things that I've learned, right? It's all about sharing, so yeah. So first and foremost, we've got this class called Perlin Line, which takes in an initial y value, right? And an offset and an x step, right? So initial y value is used for defining each of these nodes, right? Each of these lines, that is to say that, so you can, if you look closely, right? Let's say one of these, right? So this is moving here, 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 and it's tracing a path until the end of the screen, right? So this, the height is the initial y value, right? And so we can later on instantiate many instances of this Perlin line to create a complex pattern as such, right? So that is the init-wise purpose, sorry. And you've got the step value as well, right? So step governs the distance between adjacent nodes, right? And what was the next parameter? You've got an offset value as well. So I think offset is simply to not make these lines go too much beyond the screen, I guess. Let's see, we'll have to figure that out as well, because it was like a few days ago I wrote this and I've forgotten some bits of it, but nevertheless we'll figure it out, right? So I is equal to 3 and I is less than width plus 100, right? And I plus equals this dot x step. So we're simply going through a for loop, right? And so x step we are incrementing by that particular value, and this is a function draw noise points but inside of Perlin line, which essentially draws these points only, right? So what it does is it just draws it simply draws these noise points in a particular line, right? So how does that work? Let's see. So first and foremost, we define value as noise I this dot init1, right? So what the noise function essentially does is it either takes one value, right? So let's simply let's take a look at the noise. Where's the reference part? We go to noise, right? So what noise does is it either takes two values, right, x and y, or it takes three values. So these like correspond to the x and y and z coordinates we are so familiar in the dimensional side of things, right? So what noise does, it returns a value set of values that are very close. So if 2 points are close in space, right, the noise values that they have are organic. That is to say, they are similar looking, right? Right. So if one of them is, let's say, 0.5, right, the other one will be close to 0.5 in some sense, right? So I'm using noise just so that these points don't in one single line, so that these points don't stray off each other too much, right? I want them to be a little closer, if not very close, right? So that's the purpose of draw noise points. And stroke, since we want to diversify the colors, I just did, by some experimentation. These numbers, you can't hard code them, I'm sorry, but I can't visualize the HSV wheel into that level as of yet, right? But nevertheless, these numbers, I just came up with them. But you can refer these numbers. If you look closely, they look like they're multiples of 3, right? 30, 210, like degrees, right? So HSV has got this interesting thing. So you can view, if you define HSV in p5.js as where's the setup? Let's go to setup. Yep. If HSV is defined in this way, right? 360, 100, 100. So 360 is the maximum value for the hue value, right? Hue, saturation, brightness, right? HSB, right? So hue is the accent of the color. So hue is either red or cyan or lavender or baby pink or lime or anything, right? So hue defines the accent of the color. Saturation defines how much of that color is present, right? Saturation of that color in that particular mixture, right? And value or brightness defines how bright the color is, right? So those are the attributes of HSB, right? And they define how the color is created. So 0 degrees, as you can see, is red usually. I mean, always, right? And you go down the HSB wheel, right? The color wheel. So you can think of this like as being VibGyor, right? So there's this formula, violet or VIBGYOR, VibGyor, violet, indigo, blue, green, yellow, orange, and red, right? So that's how colors progress. VIBGYOR, right? So you can visualize it that way as well. So hue wheel. So saturation is the richness, as you can see here, right? You've got 100% saturation of 0 hue means that it's like fully red, right? 25% means it's got some of red present in it, but most of it is like not red, right? And brightness is simply like saying how bright the color is. Brightness of 100% like is completely white. So how would you think of white in case of HSB, right? So white can simply be 0, 0, and 100, right? Because you don't want any saturation of any accent inside of white. You just want maximum brightness and no hue as well. I mean, any hue works, honestly. If you don't have any saturation, any hue works, right? So it can be 100, 0, 100 as well. Just the middle value has to be 100. A 0, sorry. So you've got, that's how color HSB works. So I'm sorry if we're going into too much in-depth explanation of how HSB works. But essentially what I'm doing is I'm defining the stroke, right? So for the noise point to be this particular value, which is a color, right? And so there's one particular like tricky thing I did here, which is like mapping according to the height, right? So as you already know, the last value is the brightness value, right? And in this, as we can see, the brightness value decreases as we move upwards. And the coordinate system in p5.js canvases goes on like you've got, this is your screen, right? So you might, if you're watching this, you're already familiar, but the top left corner is 0, 0, right? 0, 0. And so we coordinates, y coordinate increases as you go downwards, right? So it increases as you go downward, and x coordinate increases as you go leftwards, right? So it increases as you go leftwards. That's how the coordinate system works. So at the top, right, at the least init y, it's got the least brightness, and at the max init y, it's got the max brightness. It starts from 30, so we are essentially mapping this dot init y to 0 comma width, from 0 comma width to 30 comma 100, right? So that's what this function is doing. And next up, we are simply pushing and popping and drawing a point in the screen with a stroke weight of 8, right? And if this the p vector array, which is a point vector array, if the length of that is less than math dot for width by this dot exit, that is the number of points that are possible to fit in that particular screen, then we just push into that array, else we don't push. Right? So why is this essential? So p5.js's draw function is a function that continuously loops, right? It continuously draws, right? And if you start using random values and noise values, what happens is most of the times you don't get the desired output, right? So it continuously goes and produces more and more numbers, but sometimes you may have to want to have control over that. So what I'm doing is I'm just defining that control here. So you just store the points that fit into the screen and don't iterate any further. That's what I'm telling it, right? And join points, it's used to join the points with these white lines, as you can see in this animation, right? So if I loop it again, the brighter ones here. So it essentially joins two points, right? So how it does that is it defines a stroke, which now again I'm doing the map thing for this white lines as well. As you can see, the brightness for white lines is the least up here, and it's the brightest down here, so I'm simply doing that in this particular line. And what we do is we draw line between the two consecutive points of the p vector array, right? It takes the array as a parameter, and later on in some particular function we'll be passing this p vector array into this join points function as well. And we've got join two consecutive points, so this again takes in two consecutive points and joins them, right? So now you might be wondering, right, why do I have two functions that essentially serve the same purpose, right? So the thing about these is they don't serve the same purpose, right? So you've got join points, right? Join points is very essential when we want to. So I was thinking of drawing a reverse, like it reverses as well, but this part it's like for later on implementation. But essentially what this does is, yeah, so I thought of erasing it as well, and this polarity reverser, it's simply like when the line, the animation reaches the end of the screen, I want it to again, erase and come back, and so it can create a loop, okay? A random loop. That's what I was thinking. But for the time being, this works, so I've written some to be implemented reverse animation, right? So I've not implemented that as of yet, but yeah, this is one of the showcases I wanted to show. The GitHub repo for this will be provided down in the description below. And let's go to another project that I have as well.